Continue talking about probability in this chapter. First thing, I just kind of want to go over how we draw a histogram. So if I'm given this set of data here, okay, and it specifically says histogram, okay, that's kind of like a bar graph, if you remember. But our data has to be continuous. So we can see here that it's going from 60 to 69 and then 70 to 79. It keeps going on forever. And instead of a bar graph, the bars need to touch. Okay, so if they're not touching, then we consider that a bar graph. Okay, but a histogram, the bars will touch, and that's because there's continuous data here. You can see there's not like a random jump. It's not like this is 99 to 100 here or something like that, instead of having that nice smooth jump from all of these numbers. Okay, so what we're going to do is we are going to graph this information. Now, I already drew my graph, so if you want to pause the video and draw this graph for yourself, I'll kind of explain why I did this. So this little squiggle here, okay, because I didn't start at 0, I draw this little squiggle here, so that way if someone is reading my graph, they can say, oh, okay, she had a little jump before she started, because I didn't want to have to write 10, 20, 30, 40, 50, 60 beforehand. So I just counted by tens, because that's kind of the range, that's the range right here that it is. It's from 60 to 69, right? All the way up to that 70. So that's why I counted by 10. So you'll have to look at your data to see what the range is for each of your numbers. If it was counting by 5s, I would have counted by 5s here. And then I just counted by 2s on my y-axis here, just because I was going all the way from 4 to 22. So I didn't want to count by 1s, but 2 seemed like a good alternative. So what I'm going to do now is I'm going to say, okay, 60 to 69 had 11 trees. So if I label my y-axis, this is trees. Okay, and this is the height of the trees. Okay, so we have, 11 trees at 60 to 69, so I'm going to draw my bar from 60 to 70, because it's not really included in 70, up just to that 11, and usually we'll color those bars in. Okay, and then from 70 to 79, we're going up to 20, so I'm just going to continue this line at the 70 all the way up to 20. Okay, and again, I'm going to color that in. So this is saying from 70 to 79, we had 20 trees in that height range. From 80 to 89, we had 22, so I'm just going to pop that line up a little bit and draw this straight. Whoops, sorry. My pen is not liking me pulling up from the base there. Okay, and I got a little crazy there because it was being fussy, but as you can kind of see, we're doing this, so the 90 to 99, we're going up to 15 here. So I'm going a little bit farther down now. We don't have as many trees at this height. 100 to 109 would be 6 trees. So pulling that over there, coloring that in. And then my last one is 110 to 119 is 4 trees. Okay. Again, a histogram, the bars are touching. It looks kind of like a bar graph, but not perfect, okay? And again, labeling our sides here, what do these mean? That's a good thing. Usually we'd have some sort of title of the graph, so maybe I'd have height of trees, number of trees, something like that. Maybe we need more information for a better title, but hopefully that's kind of a refresher on what a histogram looks like. We'll be using that later on in our chapter. So going back to probability, you watched our video on Friday. So we're going to talk about outcomes and sample space. So when you play a game, the game will either end in you winning, losing, or tying, right? So if we're talking about a baseball game or a football game or maybe a card game, okay? Tying doesn't happen a lot in a lot of those things, but winning and losing has to happen, right? So these are what we call the outcomes of the game. That's what comes out of the game being played. We win, we lose, or we tie, okay? All possible outcomes are what we call a sample space, okay? So we want to figure out what the sample space is of flipping a coin. So we write this kind of fancy. We write a big S is equal to, and we draw these fancy little brackets, okay? And so what is the outcome of flipping a coin? Well, one of the outcomes is heads, and the other outcomes is tails. Sometimes that is shortened to be just an H, comma T. That happens a lot with heads and tails. Okay, you can see my little brackets are not perfect every time. Okay, as long as there's kind of 3 little chunks, I'm happy with those. Okay, so when we roll a die, and our video talked about the sample space of heads and tails for a coin, and rolling a die. So a single die would be a 1, 2, 3, 4, 5, 6. So the sample space includes all of the possible outcomes, even if there's repeats. Okay. Now, if we talk about sample space for the weather, this could be very different for each person, but whatever I think of off the top of my head, if you have something to add, go for it. So I would say maybe sunny, rainy, maybe it's snow, maybe sleet. It could maybe be partly cloudy. Maybe it's just cloudy in general. Okay, so we have lots of these, right? And we have winter mixes and all that kind of stuff. So I'm just going to stop just because we could keep going on for this for probably a while. But you can see the sample space are all the possible outcomes. So I'll just kind of put a dot, dot, dot here saying we could keep going. Okay, so some sample spaces will be very small, like our heads and tails. And some sample spaces will be very large, like our weather. Okay, so you have to be kind of careful, make sure you're keeping all of those outcomes in mind. Okay. And making sure you're kind of asking yourself, is there any other outcomes that I'm not thinking of? Okay. All right. So we have this set of cards here, and I'm sorry they're not in the right color. And you record the color. What are the possible outcomes? Now this one's not asking for sample space. It's just saying what are the possible outcomes. So basically like sample space. But we could have a purple. We could have blue. We could have green. Which I only need to write that once in this case because it's not saying sample space. White or brown. Okay, so I didn't put this in the sample space brackets because it's not a full sample space because we would have to include both greens. Since it's just asking me strictly for the outcomes, I'm just going to list them. Okay, but if it says sample space, that's when you would write your S in your little brackets. Okay. All right, so an event is a collection of outcomes from an activity. So for example, if we were to roll a die, we know the outcomes, or the sample space, is 1, 2, 3, 4, 5, 6. The event of rolling an even number has an outcome of 2, 4, 6. If we were rolling an odd, it would be 1, 3, 5. So an event is something special that's happening. What do we want to happen? Okay, so if we think about the alphabet, what is the outcome of the event that you pick a vowel? So again, you can still put these in the parentheses, we just don't write S equals that. So even up here, I could put this in my little brackets if I wanted to. So if we're looking at an event for the alphabet, we're looking at vowels. So we have A, E, I, O, U. Now I know we say sometimes Y, but I'm just not going to include that here. We're just going to stick strictly with the 5 vowels that we see regularly. Okay. So the letters after W. So if you have to sing your alphabet, W, X, Y, Z. So that is the event. We get a letter after W. The only chances of that happening are with an X, a Y, and a Z. What about a consonant that comes before P? Okay. So what I would do is I would say, okay, I'm going to start. So a consonant. So A is not a consonant. B is, C, D, E is a vowel, F, G, H, I is a vowel, J, K, L, M, N, O is a vowel, and then I hit P. So the event that I get a consonant before P is all of those letters. Okay, so go ahead and try your homework. Hopefully this helps. If you need anything, please let me know. Have a great day. Bye.